So welcome back, and in this tutorial we're just going to learn how to use the new input system with some examples as well. I'm going to begin by going to the package manager. You should already know how to create a project, or you can look for others who already show that. But anyway, let's get on. So in the Unity registry you will find a package named input system. You can simply install this one. It's a new input system, and the reason why it is better to use this one is it is very easy to actually add inputs than the old input system. That was quite boring, and supporting multi-platform could actually get quite confusing. But right now let me just continue the process. So I said no to restart the editor, meaning we need to manually go and enable it now. I'm gonna go to the input manager, input system, we need to go to the player, and in the player we can get to other settings. Inside the other settings section we'll find this active input handling thing. So in the other settings you can see we got it. Now we want to set it to both, so that if you ever wanted to use the input manager while testing your game, you can actually keep on both, because you might not want to go and create bindings, which could take some time and you're just willing to test. Anyway, so I hit the apply button. He actually told me to restart the editor, and it's restarting. To take those effects, it needs us to restart. Otherwise, changes won't be saved. Alright, so now the input system is enabled. That's the end of the setup. So let's begin creating a folder. Call this one input. We can call input actions. Let's create a new input action. Setting plan, input actions. Yep, right at the bottom. I'm gonna call this one input actions, and so if you double click on it, it's gonna give you a new window, and it will show you action maps, action. But just before we do that, let's hit generate C# class and press apply. So by doing this, we'll be able to access these input actions by our script. So back to the actions input action editing window. Now the action map is basically each action map has its own actions, and that can be useful when you're making like different things the player can do. Maybe he has to sit in a boat, in a car, so you can have a boat and a different one for a car, and for the player another one. So those can be useful in that way. But right now we'll just keep one, and I'm gonna name this one. So the name, you just hit double click to rename it, and it should give you the way and enables you to rename it. So now testing is good, and it automatically creates a new action. But I think I should delete it so I can show how you add one. So basically, to add a binding, you just need to add, just hit the plus button on the right side, and here we can call what we want. It could be the movement input and all that. So we're gonna start by a very basic one, and I'm thinking I should call it should be a button, I think. So first we can go with the button, and I'm gonna name this one again. Remember, to rename, you can right click and rename, or you can double click to rename. So that's just a button, and now I think we should set it to pass through. Now the thing is, you can set it to pass through, or well, it doesn't matter for buttons. And we can keep in the binding, we can set up a new binding, so you can see different bindings it allows us to get. Now what I'm going to do is I'm gonna press listen. You can see how there's a small bug in Unity right now, and it actually is hiding those listen and text fields. Anyway, I think on Windows it doesn't do that, but I think they should fix it as soon as possible, even though I still can't see it, so that's okay. Now we can see that we can add multiple bindings in one button. The listen button basically enables you to basically just listen for input, and then you can tell it to do it. So like the space, I just press listen and press the space on my keyboard. Anyway, now we can hit save asset when we are done. Whenever you see this sign with the brackets, basically that means that right now your changes have not been saved. Or you can click autosave. The problem with autosave is I don't like it, and that's because it takes a lot of time. Every action, everything you change, will just keep saving. So I prefer no autosaving, just wait for us to finish editing, and then we should actually save. So that's why. But now let's begin by creating an empty game object. And we're gonna call this one input testing. So basically we are done actually creating the action, our first action in the action editor, and now we're gonna do the next thing. So basically we need to take input using our script. Now we have the game object already made. You can create a class, you can say input testing, and double click to open it in the Visual Studio editor. So we can define, to begin with, a private input actions. So this is actually the script we actually got it to generate, otherwise we would not be able to. Now nobody should touch that script because it's already generated. So play input actions. Now on enable, we need to do two of these methods, on enable and on disable. In the on enable method, we're gonna say input actions dot enable, and in the on disable, we can say input actions dot disable, dispose or disable. I think I'll go with disable, as I think it's a better option. Secondly, we need to get a reference on create a new one. Now let's try if start actually is able to manage this out. So let's set it to new play input actions and see if we get any errors. But before we do that, let's go into the update method. So we're gonna check for input actions dot enable. We're gonna check for testing. So you can see that action map needs to be remembered by us. Testing is the action map, so here you can see it just came. Double click to get it, and then inside the action map you'll find button, as that's the name of the action that we want, and we can actually say triggered. Now let's see how it looks with the old input system. Same code we're gonna write, but for the old. So you can see how I'm writing this exactly the same, but using the old input system. And this line of code and that line of code will do the exact same thing. But what if we want to set up two input actions? So we can say, let's add a binding, and we can say it should also trigger the input if we click D. So now what this is going to do is, if you click D, it's going to trigger the button, and if it also presses space, either one of them, it's going to trigger the button. Now this is one line of code which we don't need to touch at all in the input new one, but if you see at the old one, you have to add an all dot D, and that's quite a problem. Now we can actually go into the input manager and then do some stuff which is not at all, that's not all great. So what if we had a key gamepad binding for this one as well? And multiple other problems can occur even using the old input system. So that's why the new input system has a very nice way to actually make the actions and use them for multiple. So the code has to be same, the input action has to be modified. So now that we have this check, we can write debug.log, and we're going to log in. The action button is pressed, or you can say was triggered. So now every time you click the button, we should get this log, but just in case we get an error, we might actually get an error. I do think that we'll get an error, because I think on enable will be called and then start will be called afterwards, and that will cause an error. Let's see if it does or not now. So let's hit the play button. Don't forget to save the script from the editor. Alright, so I've hit the play button and nothing's happening, so I'll have to assume it's an error. Pressing the space keyboard, but nothing's happening. Well, actually we never added the script. Now it should work, or at least give us an error. So we have a direct error, and it says null reference exception on enable. We didn't even have a reference that until then. So we actually need to do this in the awake. I apologize for what I'm doing right now, because that won't work. At the time when I was making the video, I wasn't sure about what to do. I thought maybe I should try some other ways, though I exactly know how to do it. So it still gives the error. Until I don't use the awake function, it's not gonna have any fixes. So we need to remove this, and to have an awake function in which we're gonna write input actions. We're gonna set it to a new the input action. This is gonna cause all the errors to go now. Awake is called first, then on enable, but on enable will be called later as well. That doesn't matter. So you can see how every time we click D or we click spacebar, we have this debugs going on, and that's pretty good. So we can already see how we can take input for a button. So now that we have done with this one, let's see what else exists in the button. So you can see if we do a dot, and we can find is pressed as well. So this can be used to have a timer for clicking or interacting with something. Is pressed can be used for really anything. Usually you can use it for maybe a sprinting action. Maybe you want him to keep it pressed and then really. So now we need to add an else to see if it's pressed or not pressed. So if it is, then we want to simply write the action button is pressed, and otherwise it's not pressed. So this is gonna basically mean that if we press D or we press spacebar, we're gonna get action button is pressed. So you can see we've kept it pressed, then I've still kept it pressed, and you can see how the action button is increasing. Now the action button is not pressed is increasing, and that's basically working as well. So that's pretty easy for buttons. Now let's try some other type of input. Remove that, and should also remove this testing.o. And now let's come back in here. We're gonna add a new binding and a new action actually. So we call that one a vector2. I would rather try out axis first, and you change it to value, and then you can only give it what you want. So now usually the old input system used to have an axis, which would actually not be digital. It was digital, it would be analog, but for analog you need to actually select analog up there, but I'm not going to cover that in this video as we don't need that a lot. We're going to be using lerp later on in this video when I'm going to be showing examples of how to actually move an object. using a vector 2 input. This is an axis currently. So you can see this is positive negative binding, so usually we need this for keyboard, so we can call this keyboard. And in the negative binding, you will see we need to assign the negative button and the positive button. Forward would be positive, I think we should go with W. And for negative, we can again listen S on the keyboard. Save. And right here we are able to now access the axes that we named in the editor. Now, sorry about that. We need to read value of type float, not vector 2. I apologize for that as well. But before we fix that, let's just delete all that. Yeah. So we need to read value of type float. I don't know why I've not changed it yet. Yes, now I'll change it. Float, it's a float. It's a float. Alright. Could also be an int though. We'll simply create a new float axis and equal it to this one. And now we're gonna say debug.log and we're gonna log on axis. That's it. Now if you press the W key, you're gonna get 1. If you do not press any key, you get 0 0. And yeah, 0 0 0 I mean. Press S key, you will get -1. Let's try. So we got 1. And again, if I click back, then we get -1. If I leave, we are getting 0. So let's just remove flash so you can see it real time. Yep, so you can see 1, -1, 0, and all that's working perfectly fine. So now we can see how we can read the value of an axis. But usually, you actually need to movement. But anyway, let's see how pass-through works with an axis. You will see that there's no difference. Currently, for some reason, I don't know why they made pass-through, but pretty sure it has some difference. But anyway, we're gonna set it back to value, save asset, and back here in the script, we're going to set this one. So now we're gonna try out the most common one, which is a vector 2. We need a vector 2, not vector 3. Then we'll delete the keyboard and just fix this all. I'll select vector 2, I think, yeah. Analog that we've got. Let's add a positive, no, sorry. I mean, it should be a vector 2. Analog does not support dual. Analog is for an axis which has, similar to the old input systems. All input systems, axes, and how it works, and create a similar one. But right now we need to add an up, down, left, right composite so that we can set up the WASD keys. Now I'm just setting those up, just like I did for the axes, but for a vector 2 you need to assign left and right as well. We've got A, and we've got D. Now we can rename this one by double clicking again, get it to keyboard. We can close this, save the asset, and back in here. Now we need to get a vector 2, and it has to be a vector 2. Vector 2, we're going to read value of type vector 2 as well, and we're going to debug.log of vector 2 as well. Vector 2 was the local variable we actually created, not really the vector 2 component, not the script or whatever it is. Alright, so we are getting 0 0 1 1, now -1, and we can see how everything's working perfectly fine. Now if I click both, you can see this odd things happening here. We're getting points and 1 and points and 1. Usually this can be done for normal things, like maybe if you have basic inputs, it does fix things, but for an FPS game, something like that, maybe you don't want this. I think I usually always change it back to digital so that it always gives me 1 1 and not points and 1. So yeah, just set it to digital and save the asset. Well, actually there's multiple other things you can do with the new input system. It's actually highly advanced, and you have multiple interactions, processors, and many other things. So if you look at this button, what if you want to add a multi-tap thing? Like you want the player to double tap to do something. Maybe you want him to double tap triangle on a gamepad or on a computer to put his weapon back or something like that. Now you can see how I just added an interaction of multi-tap, and I'm going to just demonstrate how it works. If I set this to 4 taps, that's a lot. Anyway, I'm going to go to 2 right now. Let's create on the D keyboard a hold. Let's go with the hold, yeah. Multi-tap also, and this one can be 3. So if we click D 3 times, we're going to trigger the button action. If we click space 2 times, we're still going to trigger the input, the action. So that's the cool thing, is we're gonna again only need to write that one line that we wrote before. I don't know how we would do that for the new one, the old one I mean. The new one's quite simple, and that's why I made this video, so everybody else can actually use this one and understand how it actually works and why it's so simple. We just debug the log that, save, come out. Let's open that console window and let's see. So now you can actually do it yourself as well. So I'm gonna hit the space key 2 times, and yep, we get a debug.log there after I click it 2 times, not once. Now for the D keyboard, you can see if I click it 3 times, wow, so 3 times as well it works, and that's basically really cool. So we can have hold, press, step, and many other things already provided for us by the new input systems. So let's just delete the button, and let's now do some other things. We'll create this movement, so vector 2, and we're gonna now demonstrate how to use this vector 2 to move our things around. Maybe you want to transform it. For now we're gonna do that in the next part. Alright, now we're gonna implement some movement. So we're gonna say input actions equals which means, yeah, we need to define a vector 2, and I'm gonna create a vector 2 input vector vector 2 whatever, movement vector, and set it to input actions dot testing again, because that's the action map. We define the movement vector inside, and we can find the movement dot read value of type vector 2, and there you are. So we have it set up. So now we have the movement vector, and we can write transform dot position. We're going to add this movement vector multiplied by, well, let's give this an error right now, and that's because movement vector is a vector 2, and what the transform position is a vector 3. So we can just define a new one, new vector 3, and we're going to give it 3 different values, 0, 0, 0, and for the movement vector we need to smooth it, I think. So let's try smoothing it first. Let's create movement vector.y. Oh well, delete that. The movement vector.y is actually up down, meaning the WS is going to be affecting the movement vector y, and the z-axis in real world is the forward backward. So we need to pass in movement vector.y there on the z-axis, and x on the x-axis, and 0 on the y-axis, because y-axis is up and down actually in Unity. Alright, now we have this game object. It's not working, I think, is it? Yes, it is. So you can see that it's quite snappy, not all smooth, and we look really just boosting here and there very fast, and that's not great. And why is this happening? That's because we're doing this every update, and we don't multiply it by time with delta time, which is the frame rate currently. You can simply multiply it by time delta time and multiply it by a speed variable which we're about to define. And simply just define this for testing speed variable, and we're going to make a public float speed. I think we should go as private, and as serialized field actually overrides it, it will simply zeros the field. Public is not always good. You should only make it public whenever it's required. Actually, you can actually watch someone else's video on that. I think. Let's see what's happening here. So we can already see that it's way better than previously, and it's pretty smooth now. Not so jittery as it was before. The speed is 10. So we need to smooth the vector because it's still having a bit of a jittery problem. If you look, as soon as you press the key like W or A, it just snaps to 1, which means movement vector to Y or movement vector to X is going to be 1, causing it to start moving as soon as it actually gives input. So we need to actually learn this movement vector somehow. So the way to do this is to make a new vector 2, call that one the smooth vector, equal it to a vector 2.lerp. We're going to lerp it from the smooth vector to the movement vector, and we're going to do a smooth speed of input, so basically time and delta time multiplied by, and now we need to have a new serialized field, and this has to be private, and this is also a float. This time this is going to be the smooth input speed equals to, I'm going to say it should be 20, so 20. You're going to simply time delta time multiplied by smooth input speed, and on the smooth vector getting an error, and that's because he wants us to define the variable, because we're actually defining it, and then we actually are trying to get it again. Before we define it, we can't access it, so we need to set that as a private field already defined, and that should do it. And instead of the movement vector, we need to pass in smooth vector, smooth vector.x, and for the movement vector instead we need to have smooth vector. Alright, so now you'll see our input has become really nice and smooth, everything's perfectly fine, and we've got a similar effect that we used to get easily using the input old one. But if you look here, this is a way better way of doing it. And the reason why I'm saying this is because you can now add 10 bindings to the movement, like maybe you have some different types of gamepads, different settings, and all that can happen in this input system without changing the script at all. You just need to go in the movement and modify that. So that's why this is a great option for input. Now we're done. Let's see how we can use another action type. I'm gonna go with value, and we'll set this one too. I think we should try out. No, I think we have just no. Let's see. We have access dead zone, hit scale, invert, clamp, and many other things. Still have these as special things, but as I don't need it, we just do that. So now as a bonus, we're gonna do some other things as well. Let's see what we do next. I think we should try out using the character controller component. I won't explain that in depth though, but I will show how we can use that move function to actually move it. Alright then, so we need to begin that in the next part. Well, actually this part is for the basic look effect. So we're gonna again need to get the mouse's position, or it could also be the right stick of a gamepad. And again, I can say it's a great input system, that's why I add multiple bindings. So create a new look vector. Action, vector 2, value, action type, control type is vector 2. Now we need to pass in. Basically a vector 2. Now if you go into the mouse, you can find this delta, and that's the one I always go with because it actually gives everything correctly well, and that's how you get the mouse input. So Let's do that right here and right now. Vector 2 look vector. Set it to input actions dot testing dot testing dot look vector dot read value. And again, this is a vector 2, so we need to read value of type vector 2. Now, as the main camera has not been touched, the Unity will still have a full reference to it, and we can simply write camera.main to transform the rotation, and we can set this to quaternion. Quaternion.Euler. So Euler just turns on, ignores the W value of a quaternion, and it just converts it into an Euler value of vector 3, which is what we want here. And we can set that to 0 now. You can see how the main camera is currently set to 1 minus 10 rotation. So if you see, we know the x-axis is what's going to cause the up-down type of rotation, and for the rotations on the, basically it's going to be y-axis, so we need to know exactly which axis we need. And just so that we can actually see what we're doing when we're looking around, I'm going to reset this cube, position it right there, duplicate some more, and paste it in there. Command C, Command V, that's all, or Control C, Control V. So let's go back to the script, and right here we can now assign the correct ones. So basically we need to change the x and y, meaning the z-axis can be left alone. So before we do anything, we need to define two floats. The first one is for the x rotation. The second one is for the y rotation. Let's go down here where we got the look vector. We can actually change the x rotation and set it to x rotation, say plus equals the look vector. Now, because x rotation is what's going to cause the up-down, meaning up-down axis, we need to give in y, because y is the up-down on the mouse. Now for the y rotation, we need to simply give in look vector.x, because x is the left-right, and y is what will cause that rotation. To study more on this axis thing, you can look for another video on this topic, but it's quite simple, so you should be able to understand it. The y-axis and the x-axis of the look vector is different than the original axes in Unity. Now back to the camera's transformation modification. We can change it, and as we want to pass in the y rotation, we can give in the y rotation. For the x-axis, again, we're going to pass in x rotation. And once we're done with that, we have this setup. So I'm going to be having a basic FPS movements at the end of this video. You'll see, if you keep with me and not miss any steps. Now, if you see, we have this camera movement. We can do up and down. There's a funny thing going on here. So left right's working well, but up and down is not going well. That's because we need to give in minus equals on the y, which I forgot. Now that we did that, we can hit the play button, and you'll see we got a proper look here and there around. I can do everything I want. So we can move the input testing game object. Now let's actually drag this into the input testing, which is usually done by FPS makers. It's not a great thing to do. I'm gonna remove it in a bit, but just to see what happens. Now you can see the most biggest problem here. Even though I'm looking there, if I press the W key, I'm supposed to move in that direction, right? Now we are actually moving based on the vector 3 origin points. We're not using the transforms forwards or the transforms right. We'll do that in the next section. And yes, we're back again. So let's go into the script. Right here, define a new vector 3, and I'm gonna call this the move direction as a short form. We're gonna set this to 2 brackets. Now, what are we gonna put in these? Well, it's going to be like a multiplication of the forward axis and the y on the smooth vector. So let's do smooth vector multiplied by smooth vector to y multiplied by transform that forward. And then in the other one, you see to add these together. Smooth vector multiplied by transform that right. So now move direction is set up to be actually moving correctly. Now we can remove this vector 3 as we already have one, and we can set move here multiplied by time or delta time. Now if we hit the play button after saving the script, you should notice that well, something else went wrong here. Well, you would have noticed that we forgot to drag the main camera again inside. Alright, now we are still moving forward and backward depending on the axis of the origin, but actually we aren't. We are actually getting the forward. The way to fix this is to modify the transform.rotation.y instead of modifying only the cameras. So we will modify the y rotation on the camera, and on the transform.rotation we are going to modify the only the y axis. So quaternion Euler again. So you can see how 0, 0 and rotation only y. Alright, so you can see now that we are looking around, the main camera kind of stays at 0, tries to at least, and input testing is moving in the correct position. Now just to demonstrate, I'm going to reset this plane at 0, 0, put by 10, and the cubes need to be a little up. We need to use the character controller for movement instead. Let's try it out. Let's add a component of type character controller, and then let's go back to the script, and we're gonna say controller. Now I don't want this actually. It still got me that. Controller.move. Maybe giving me errors for now, but I'll fix that in a bit. Because controller we don't have a reference yet to it anyway. So I'm going to move with the move direction multiplied by time.delta time again, which is the time between each frame, multiplied by speed. Then we need to create a private character controller and call it controller. And in the start function, we're going to say controller.get component. I think but yes, so I just made a mistake here when I was making the video again, and it's actually supposed to be controller equals get component. I will fix that when I find out it's actually a problem. Now because we're gonna be doing bonus as a rigid body as well, so I'm just gonna create that as well, just right here. So when we're doing later on, I'm just gonna comment it out as well, as we're not using it right now. Now, as I'm gonna get an error because when I was recording it, I did not remove that dot and add an equal to. Yep, so we have an error directly, right away. The error is right up here, where he can't get the component. Yep, there you are, fixed it. Now you will see that we have everything set up almost done. But we haven't set up the character controller correctly yet. If I look around, everything's fell. And let's move. Oh well, that was funny. Just hit the ball. Now you can see how the player has moved 1 up, and that's because the controller is actually half in the ground. To fix this, we can simply set the offset value of the center to 1. On the main camera, set it to 1.6, so that we have a bit of VX. Oh well, let's kind of fix this issue here. We can't have the main camera as the child, okay? Move that out right now. Instead, create an empty game object in there and call it cam holder. In the cam holder, we'll add a new script. Now, I'm gonna name this. Well, that's a big mistake here. I'm gonna name this camera actually, and that's gonna cause me an error, which I'll fix later on in this video. Let that happen in a bit. So it's camera, and double click to come in here. Find a private transform which is serialized and called target. Then we're gonna follow its transform position and rotation every update. So we keep it same. That should do it. Alright, so we have a funny issue here. And we're getting an error directly that the camera, and that's because we actually defined our own camera, and that's not great because Unity already has a script named camera somewhere inside somewhere which actually gives you this reference to the main camera, and it's not working anymore. But actually it doesn't matter to us anyway. We'll remove that. I think it's happening because of our own script that we created, and I'll rename that in a bit, no problem. But why is it working? Yeah, it's exactly that one. Anyway, change the name to cam holder because that's what we actually want now. Serialized field transform is gonna be private one as well. Copy from above. Alright. So now we can actually give in something. Well, see, I said that was an issue. It already says that camera has the same name as the built-in component. Thank you very much for telling me that, but I'm now gonna rename that one to controller. Go up into the camera controller script and rename the class because that will still keep interfering with the original camera class. Save it and then come back here, and the error would have gone by now. So you can see we can still access the main camera. Alright, great, fine. Now let's come back here, and in the input testing, if you look at we can assign that cam holder. For the main camera, we'll assign the camera controller, and given the reference, the target is cam holder. Alright, and we don't want a camera controller here. Move the component. Okay, now we can hit the play button. Well, I've noticed a clear issue is it's kind of under the ground, and even if after we come up on the ground, it's still having an issue. So let's go back here into the input testing. I'm gonna set this controller to 0.02, and the height to 1.8. I will not cover how to actually clamp the look on the x-axis. It's quite simple actually, but as I have not covered it, it's a good idea to actually go and watch the FPS series for the full body, and you'll find out how to do that. Though I should tell you how to do that though. In the description I'll show how to do that. Alright, fine. Anyway, let's just remove these things and keep this at force. Let's do the bonus user rigid body for movement. So to begin with, we're gonna remove the command, and we're gonna say controller instead of RB, and we're gonna add force. We must change the type also to rigid body so we can access it. Move dir, multiply by 10 time the total time, multiply by speed. Even though we've written so happily, it won't work because it's actually a physics object. Usually this can be confusing. We try out force mode to the velocity change. Now if controller velocity dot magnitude is greater than a max speed which we have not defined yet, controller dot velocity dot magnitude equals vector 3 uptown clamp magnitude. I'm gonna clamp the node deer to the max speed. Well, actually, this is controller, I think. Well, it's getting an error anyway. Has to be controller dot velocity, and right here remove the magnitude. Now let's define this variable. Let's go back up here, paste it here, take it from above here and make it a float. Then we need to remove the space. Max speed can be 5 right now, and for getting the component we set rigid body. Now for now you can just try out without the force mode. Default is false, so it's gonna be false. Let's see how it works, and you also need to do greater than or equal to, and we can hit the play button. Oh, the input testing does not have the rigid body component yet. Remove the character controller, rather add the rigid body component. Remove the character controller, and let's see, set continuous dynamic. Weight is 70 kilos. Average, I would say, maybe. Anyway, freeze all the rotations. We don't want it to physically do anything to it. Well, it just fell through the floor. Now that's because we don't have any collider. We need to add a capsule collider. And the capsule collider is going to have an offset of 1, so it's right up in the center, and the radius 0.5, while the height is 2. Hitting the play button, you'll see what I mean. Now we can look around, but we can't move. That's because the rigid body, whose weight is quite a lot, and not only that, I think the force isn't really working. Let's see if we increase it. No, nothing is working. It seems to be moving very slowly, but even if it was moving, that's not what I want to do. Nope, no effect. So I think the only way is to come here, and we're clamping the magnitude. That's okay, but we need to change the force mode to velocity change. Yep, think so. It should work now. Yep, so it is quite slow, but it does actually collide with the object as the controller character controller. So yep, it's alright here now. Yes, I think we need to change the speed and modify the drag and all that to get to perfection in rigid bodies. Usually I prefer the character control component, but if you make a physical game, like, it has to do multiple interactions which are physical, then you should go with rigid body, because the character control component cannot interact with physics bodies. Like a rigid body can't push it or do anything with it. You need to do a special setting for that, and that's via script. So here we can see how we can modify drag and the videos, and that's it. So all that will fix everything, and we've learned the new input system.